Hello, ninth class students. Previously, atoms and molecules was a separate chapter. What is inside an atom was a separate chapter, and chemical reactions and equations was a separate chapter. But now, these atoms and molecules chapter has been combined with chemical equations. Okay, so in previous videos, we have covered atoms and molecules and the chapter what is inside an atom. Now, I am going to teach you the chemical equations and reactions separately. Okay, so for that, first I'll be giving you the digital videos, then it is followed by my explanation, so that you can understand or just at least be familiar with the visuals which you see in the video, so that my explanation will be easy for you to grasp. Okay, students, so watch these videos and try to save these videos in your pen drives, whatever digital content I am giving. For explanation part, anyhow I am there, you can use the Zoom sessions which are available with our classes.
Hello friends, this video on chemical reactions and equations part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Let's take some example to balance a chemical reaction. So we have nitrogen plus hydrogen give NH3. Let's see if it is balanced or not. So the first element will go by priority. The first element we should go for is nitrogen, right? Because there is no metal, non-metal nitrogen is there. But we told that the hydrogen oxygen is the least priority. The second priority will be for the hydrogen. So first we'll try to balance nitrogen. So we'll see here nitrogen, hydrogen, right? So we'll see this is my reactant, this is my product. Right, this is my reactant, this is my product. So number of nitrogen in reactant 2, in product 1. It is not balanced, right? That means I have to multiply this by 2. So you get 2, correct? So I have to multiply this by 2. So what you get is N2 plus H2 is equal to 2NH3. I told you we can't change the formula, but we can multiply by any number. This is my new formula now. Now let's check if it is balanced. Again we have this nitrogen hydrogen reactant product. So nitrogen, how many we have? 2 in reactant. Product, how many we have now? 2. Hydrogen we have 2 here, and here we have 6. That means if you multiply this thing by 3, my things will be balanced, correct? So I'll multiply this thing by 3. So what I get new formula is N2 plus 3H2 is equal to 2NH3. Now let's see if it is balanced. Nitrogen, hydrogen, reactant product. So nitrogen how many? 2. Hydrogen how many? Nitrogen here 2. Hydrogen will see reactant 6. Product how many hydrogen? 6. So if you see that they are balanced. So this is my balanced chemical equation. So what I have done is, if you note, first thing I did was I found is there any compound element. There is no compound element in this case. Then I found any metal, no metal. Any non-metal, yes, we got nitrogen and hydrogen. Then we first tried nitrogen, hydrogen last, because I told that hydrogen and oxygen has the least priority. So this is my order of checking now. I took check nitrogen, hydrogen. It was not balanced. So there were only 2 nitrogens here and 1 nitrogen here. So I multiplied into 2 the product side, because product side only 1. I got this equation. Then again check here, nitrogen was balanced but hydrogen was not balanced. Here the reactant side had only 2 nitrogens, 2 hydrogens. So we multiplied this guy with 3. Then we check, yes, everything is balanced. Thus I got a balanced chemical reaction. Let's take one more example. CH4, the methane, plus oxygen is equal to H2O plus CO2. Now, is there any compound? No. Is there any metal? No. Non-metal, yes. So we have carbon, hydrogen, oxygen. So hydrogen, oxygen is the least priority. The first will be hydrogen, carbon, and hydrogen, oxygen will be the next. So you can write CHO or COH, doesn't matter. So I'll write CHO. So first I'll check for carbon. So CHO I have to check. Carbon is, this is the reactant, this is the product. This is my reactant side, this is my product side. So in reactant side I have one carbon and product side I have one carbon. Carbon is balanced. Next check hydrogen. There are 4 hydrogens here. There are 2 hydrogens here. Correct. That means this is not balanced. So I have to multiply this guy with 2. Correct. So I'll get 4 hydrogens. So let's multiply this. So the new equation I'll get is CH4 plus O2 is equal to 2H2O plus CO2. Please note I'm not changing this formula, but I'm just multiplying this number. So what now I get is, I'll again write CHO, reaction product. Again I'll check the value count, the number of carbon, because it may change. So carbon is 1, product is 1. Hydrogen we have 4 here and we have 4 here. Oxygen we have 2 here and we have 2 plus 2, 4 here, right? So oxygen is not balanced. That means I have to multiply this guy with 2. So I'll multiply this guy with 2. So what I now get is CH4 plus 2O2 is equal to 2H2O plus CO2. Correct? Let's check if it is balanced or not. So we have CHO, we have reactant, we have product. How many carbon elements? 1 in reactant. How many carbon elements in product? 1. Hydrogen we have 4 here. We have 4 here. Oxygen we have 4 here. And we have 2 plus 2 4 here. So if you see, it is balanced. So this is my balanced chemical equation. Simple. Let's take one more example. We have C4H10. You burn this with oxygen, you get carbon dioxide and water. So this is an example of reaction. We'll learn this kind of reaction actually. This is an example of a reaction actually, where things, you burn things. So here you see, in this reaction, let's again see the priority. Is there any compound? No. Metal? No. Non-metal? Yes. The carbon will take the first priority. Hydrogen and oxygen will take the next priority, right? So CHO is my priority. So in this case, we'll see how many CHOs here. This is my reactant, this is my product. So in reactant side, we have 4 carbon, and product side, we have only 1 carbon, right? So this is not matching. So let's multiply this guy with 4, right? So you get 4. So let's see how much it is. It becomes C4H10 plus O2, that gives 4 CO2 plus H2O. Now let's again compare the numbers here. CHO, this becomes 4, and the product we have 4. The carbon is balanced. Next is hydrogen. We have 10 here. We have 2 here. Correct? So that means we multiply this with 5. Let's multiply this with 5. So what you get is C4H10 plus O2 gives 4 CO2 plus 5 H2. Let's again compare CHO, reaction product, carbon is 4, product carbon is 4, hydrogen we have 10, hydrogen we have 10, oxygen we have 2 here, and oxygen we have 4 into 2, 8 plus 5 is 13 we have. So here we have 2, here we have 13. So let's multiply by 13 by 2. Correct? So if we multiply by 13 by 2, C4H10 plus O2, 13 by 2 O2 is equal to 4 CO2 plus 5 H2. So what you get is, now if you compare CHO, reaction product, carbon is 4 and 4. Hydrogen is 10 here, 10 here. Oxygen is 13 by 2 into 2 is 13 here. Here you have 4 into 2, 8 plus 5. Things are balanced. But the last rule says that there should not be any fraction, but here's a fraction here, right? So we'll multiply everything with 2 because it was divided by 2. 13 by 2, so let's multiply everything by 2 to make sure there is no fraction here. So this becomes 2C4H10 plus 13O2 gives 4 into 2 is 8 CO2 plus 5 into 2 is 10 H2. and this is my balanced chemical reaction. So here we have seen that the extra part was we got a fraction here and we were told that there should not be a fraction. So we multiplied everything with 2 and we got non-fraction part. Let's take one more example. We have AgNO3 silver nitrate plus MgCl2 magnesium chloride give AgCl, that is silver chloride, plus MgNO3 to magnesium nitrate. So we'll balance this. So again the same formula. Is there any polyatomic thing which is there in both reactant and product? So we see there is one polyatomic thing, but is this in reactant and product both? You have to check that. Yes, it is. We see NO3 is here also, here also. That means my first priority will be NO3. Correct? Why? Because this NO3 is there in both reaction and product, and there is a polyatomic thing. Second thing, let's check for any metal. Yes, we have two metals, Ag and Mg. So let's write Ag and Mg here. You can write Mg, Ag also, doesn't matter. So these are two metals. This is my polyatomic thing. And is there any non-metal? Yes, we have chlorine here. So chlorine is the last. Any other thing? No. Because this oxygen is covered as part of NO3. So this is one unit actually. We'll consider this guy as 1 unit. This guy also 1 unit. So that's all we have. So first let's balance the NO3 part if it is not balanced. So let's see. You have NO3, AgMgCl. So we have reactant and product. So NO3 is how many molecules? 1. And product we have 2. Oops, it is not balanced. Correct? It is not balanced. So we multiply this guy with 2. So let's multiply this guy with 2. So what you get is 2 AgNO3 plus MgCl2 gives AgCl plus MgNO3 2. Correct? We multiplied this guy with 2. Now again let's check if it is balanced or not. So we have NO3 Ag MgCl. NO3 is 2 here, 2 also here. Done. Ag is 2 here and 1 here. 2, 1. Oops, it is not balanced again. Correct? This guy is not balanced. So let's multiply this guy again with 2. So you get 2 Ag. So what I'm getting next equation is 2 AgNO3. This I'll write same. Plus MgCl2 also I'll write same. This becomes 2 AgCl plus MgNO3 2. Correct? Now let's again compare. You have NO3, Ag, MgCl. This is reactant, this is product. So NO3 is 2 here, here is 2, 2, 2. Silver is 2 here, 2 here, correct. Magnesium is 1 here, 1 here, correct. Chlorine is 2 here and 2 here, 2, 2. So if you see everything is balanced, thus I can say that this is my balanced chemical equation. So what we have seen is, first we balance that polyatomic thing, then we balance metals, and then we. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1. So why do we need chemical equation? Till now we have learned chemical reactions, right? Till now we have done we know what is chemical reaction, where some chemical change, we have reactant product. Now we are learning chemical equation. Why do we need chemical equation? The first thing is, instead of using magnesium, oxygen and all, we can use a short form of that, right? Also we can use short form. Also we can balance it. Balance it why? Because the law of conservation of mass says that you can't create, you can't destroy mass. So if you have one magnesium atom here, it has to be one magnesium atom here also, right? Yeah, if you have some, let's suppose 2 oxygen atom, then you should have 2 oxygen atom here also. So those kind of balancing we can do if we have a chemical equations. Also, we use a short term of the name. So It's the same thing. When you say magnesium plus oxygen, you have magnesium, you have oxygen, it gives magnesium oxide. This is nothing but a chemical equation, right? So chemical equation, you can write this is my reactant, this is the product. Also, we can write what is required. So in this case, heat is required. So just above the arrow, we can write the condition that is required to produce the output. This is a typical example of a chemical reaction. You have the reactant, you have product, chemical equation, and then you have this extra conditions required, right? For example, you have a more scenario. So we have carbon monoxide plus hydrogen, both were gases, and we provided some 340 atom. We got CH3OH, and this is the liquid in shape L. So I'll explain you what all these LG means. For example, we have carbon dioxide with water, and we pass this with sunlight and chlorophyll. This is nothing but a photosynthesis process. We have carbon dioxide in water and sunlight and chlorophyll. You get this, and this is aqueous solution plus oxygen you get, which we breathe, right? We say that tree take carbon dioxide, and trees give oxygen, right? This is what happens in tree. This is the process of photosynthesis actually. So where what happens is the tree takes carbon dioxide, tree takes water, which we give water to the tree. In presence of sunlight and chlorophyll, only in days tree produces oxygen and chlorophyll. It produces this substance, and this is nothing but the food for, this is the food for tree, right? So this is a typical example of chemical equation where we write everything in the short form, right? Also we write the state of this. For example, this is aqueous, this is a liquid, and this is gas. So I'll take you through the states of chemicals in the typical chemical reaction. Aqueous solution is something which is dissolved in water, right? This is coming from the word aqua. For example, you take salt, the common salt which you use, NaCl. This is actually, if you see, it's a solid thing, right? It's a dry, the solid thing. But the moment you put in water, this becomes a aqueous solution. Correct? This becomes an aqueous solution. So why? Because NaCl, if you see, is nothing but Na plus and Cl minus ions. There's an ionic bond. We'll explain all these bonds in the later chapters. So the bond breaks, and in the water, this Na plus and Cl minus, no, this bond, this flows actually. You have this water, you have this Na plus, Cl minus, this thing flows actually in this. And this is aqueous solution because it's a partially dissolved thing. It's aqueous kind of stuff. Liquid is total liquid, for example, water or any juice, it's all liquid. Insoluble is insoluble solid is you get the actual solid. For example, iron is a solid, right? Iron is a solid. Copper, zinc, gold, silver. These are all solid because they don't dissolve in water. And then you have gas. Gas, you know that it has fumes and all those things are gas. So you have four states typically. Solid, liquid, gas, I think you're aware. Aqueous is nothing but, you can say that some substance that is partially or that is dissolved in water is called aqueous. It's in dissolved state. So the basic principle of a chemical equation is it should be balanced, because the law of conservation of mass that we have studied in class 9 says that mass can neither be created nor can be destroyed in any chemical reaction. So you can't neither create nor destroy, right? You can't create or destroy any element in any chemical equation. That is, the total mass of element present in the product of chemical reaction has to be equal to the total mass in the reactant. So this guy is a reactant, and this guy is a product. So mass has to be same, right? So you're talking about the reactant. For example, this guy has, let's suppose, 5 oxygen, 3 hydrogen, and 8 nitrogen. Let's suppose some equation. Here also it should have similar number of oxygen, hydrogen, and nitrogen. It has to be balanced, and that is what the law of conservation of mass says, right? That is, the number of atoms of each element remains same before and after a chemical reaction. This is a very critical thing that you should know, that the law of conservation of mass says that you can't create or destroy mass, so that for any chemical reaction, the number of elements of any atom, number of atoms of each element has to be same before and after chemical. For example, if you see this guy is my reactants and this guy is my product. So here if you see magnesium is how many? Magnesium is 2. Here also magnesium is 2, 2 into Mg. Oxygen is 2, O2. Here also oxygen is how much? 2 into 1, that is 2. So if you see that magnesium and oxygens both are 2. Here also we will take one more example. You add zinc to H2SO4 sulfuric acid, you get ZnSO4, zinc sulfate and hydrogen gases. So here also if you see the zinc element in reactant is 1, product also 1. The sulfate count in reactant is 1 and product is 1. The hydrogen count in reactant is 1 and product is 2 and product is also 2. So this is also a balanced chemical equation, right? Any equation has to be balanced. So we'll do some exercise on the balanced chemical equation. We'll take some equations and we'll find out if it is balanced or not. So the first equation is zinc plus H2SO4 is equal to ZnSO4 plus H. So let's see if it is balanced or not. So you have this reactant and you have this product. So in reactant you have zinc. How many zinc? 1 zinc. In product how many zinc? 1 zinc. Zinc is balanced. Let's take sulfate SO4. It's a compound actually, so we'll take this is in one go. So SO4 is how much in reactant? 1. Product is how much? 1. Correct. Let's take H, hydrogen. Hydrogen reactant how many? 2. In product how many? 1. So it is not balanced. It is not balanced. So this guy is not balanced. To make it balanced, you have to make it H2. Then only it will get balanced. If it is not H2, it is not balanced. Let's take this example. Fe plus H2O is equal to Fe3O4 plus hydrogen. So here also we have, let me write here, iron, hydrogen and oxygen. 3 molecules we have in reactant and we have in product. Number of iron molecules in reactant is 1, in product is 3. So if you see iron itself is not balanced, so we don't need to find other things. We can say that it is not balanced because the iron itself is not balanced. We'll take carbon monoxide and hydrogen. We'll get this. So we'll see if it is balanced or not. So in this case we have carbon, hydrogen and oxygen. So we have this reactant and product. So carbon we have 1 here. In product also we have 1. Hydrogen we have 2 here and product we have 3 plus 1, 4. So we can say that this guy is also not balanced. Correct. Let's take one more example. Carbon dioxide plus water is equal to this food of tree plus oxygen. Then this happens in presence of sunlight and chlorophyll. Right. So if you see here, this has carbon, hydrogen, oxygen. Right. So in reactant and we have product. So in reactant we have how many carbons? 6 carbons. In product how many carbons we have? C6, that is 6 carbon. Right. So if it is 6C or C6, both are 6 carbon. Right. Hydrogen, how many hydrogen we have? 6 into 2, 12. Here we have H12, that is 12 hydrogen. Oxygen we have 6 into 2, 12 plus 6 into 1, 6. 12 plus 6, 18. Here we have 6 plus 12, 6 into 12, 18. So if you see that they are all balanced. So we have seen some of the equations here are not balanced. But we are told that all the equation has to be balanced, right? Chemical equation. So how should we balance a unbalanced chemical equation? So here is the rule, the priority wise. First, balance polyatomic things, right? If exist. For example, SO4, OH, NO3. These are polyatomic things. If it exists in And also if this should exist both in reactant and product. We'll take some examples to explain that. So if such kind of thing exists in both reactant and product, first balance that, then balance metals, then non-metals, and in that also hydrogen and oxygen are supposed to be balanced last. Why? Because there are plenty of hydrogen and oxygen around, right? So we generally balance at last. And also if you get something in fraction, then make sure that you remove the fraction. That means, for example, you get something like this, 2 by 3 somewhere, right? So 2 by 3 x plus y is equal to z. So you can't have like this. So you have to multiply everything with 3. So it becomes 2x plus 3y is equal to 3z. So something of that sort. You can't have a fraction kind of stuff. Also note the critical thing. You can't change the formula. So if you have the equation, you can't change it, right? For example, you say that H2 plus O2 is equal to H2O. You will say that no, let me make it 2. You can't change that. If it is H2O, it has to be H2. You can't change the formula, right? You can't change, should not change the formula. That is a critical thing here. Don't change the formula. You can add any number. For example, you can add 3 here, 2 here, 5 here, 8 here. Any number you can add to make sure it's balanced, but you can't change the formula. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again. Hello friends, this video on chemical reactions and equations part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Let's take one more example. We have KClO3 plus KCl is equal to KCl plus O2. You have to balance this. So we'll see any polyatomic thing. ClO3 is a polyatomic thing, but it is not here. So we'll not consider this. Correct? Please note, here ClO3 was a polyatomic thing, but it is not there in the product thing. So we'll not compare this. We'll not consider this. Correct? So ClO3 is not considered. Any metal? No. Non-metal? Potassium, chlorine, oxygen, all. So oxygen will put in last because oxygen, hydrogen has least priority. So let's see the balance thing. KClO. This is my reactant, this is my product. Potassium is 1, 2, and product there is only 1 potassium. It is not balanced. Let's multiply this guy with 2. So what you get is KClO3 plus KCl is equal to 2 KCl plus O2. Now let's again see it is balanced or not. KClO. Potassium is 2 here. Here also 2. Chlorine is 1 plus 1, 2. Here also 2. Oxygen is here 3. Here it is 2. This is not balanced. So we'll multiply this guy with 3 by 2. So let's multiply this guy with 3 by 2. So what you get here is KClO3 plus KCl is equal to 2 KCl plus 3 by 2 O2. Let's see if it is balanced now. KClO. Potassium is 2 here. Product also 2. Chlorine is 1 plus 1, 2 here. Product also 2. 2 KCl, right? So 2 chlorine. Oxygen is 3 here. Here also 3 by 2 into 2, 3. So it is balanced, but there is a fraction part, right? So when you remove the fraction part, it is by 2. You multiply everything into 2. So what you get is 2 KClO3, this becomes 2 plus 2 KCl is equal to 2 into 2 becomes 4 KCl plus 3 O2. And this is my balanced chemical reaction. We'll take one more example. I'm taking more equations because the most critical part of the chemical equation. You should know how to balance the chemical equation. That's the foundation of the chemistry, you can say. So we have HNO3 plus COH2. It gives CaNO3 2 plus H2. This is one chemical equation. Even if you don't know about this compounds, it's okay. You should just know how to balance the chemical reactions. So let's balance this. So here we have some compound. Is there any compound? Yes, NO3, NO3. So this guy is there in both reaction and product. So we'll take NO3 as the first priority. Then we'll take metals. No, non-metals. We have calcium. And then we have hydrogen, oxygen. So we'll say hydrogen, oxygen. Right. So now we'll check this. This is my priority order, right? Priority order. We'll check NO3 part. Reactant and product. So my reactant has 1 NO3. Product has 2. It is not balanced. So we'll multiply this guy with 2. So what you get is 2H NO3 plus COH2 is equal to CNO3 2 plus H2. Please note here OH was also one polyatomic thing, but OH is not here. It's only in the reactant, so we didn't take OH, right? But NO3 is also polyatomic thing. It is there in reactant and product both, so we took NO3. Hope you understand this, that polyatomic thing has to be there in both sides to take that. So we got this equation. Now let's compare. So we have this NO3 CaHNO. NO3 is how many? 2 here. Reactant and product. Product also we have 2. It is balanced. Calcium we have 1. Here also calcium we have 1. Right? 1, 1. Hydrogen we have 2 plus 2, 4. Right? 2 plus 2, 4 here. Here we have 2 hydrogens. So hydrogen is not balanced, right? See, this part you can't take, this part is again gone. So 2 hydrogen here plus this again we can take, because this here we have not assumed as a polyatomic thing because this was not there in the product side, right? So we'll take 2 hydrogen from here, 2 plus 2, 4 hydrogens. Here we have 2 hydrogen. Please pay attention here. Since OH was a polyatomic thing, yes, but still we could not take this as one unit because this guy is only in reactant, not in product. So when we talk about hydrogen, we'll take hydrogen from this also, right? So hydrogen 2 plus 2, 4 here, and we have only 2 hydrogen here, not balanced. So we multiply this guy with 2. So what you get is 2H NO3 plus CaOH2 gives CaNO3 2 plus 2H2. Now let's check if it is balanced or not. We have NO3CHO, we have reactant, then we have product. Reactant NO3 is here is 2 molecule. In product we have NO3 2. Calcium we have 1 here and we have 1 here, 1 1. Hydrogen we have 2 plus 2 4 here, and here we have 2 oxygen. So please note, we will not take this oxygen because this is already counted as part of NO3. We will not take oxygen in this also because this is already counted as part of NO3. But we'll take this oxygen. Why? Because this OH we have not considered as the you can say polyatomic thing in the priority list because the product didn't have this OH. So we'll take OH from here, but we'll not take O from here. Please note once again, we'll not take oxygen from NO3 now. We'll not consider that because it's already counted for, but we'll take O from this because OH is not counted for, right? OH we didn't consider because OH was not there in the product side. So for oxygen we have 2 oxygen here, and here we have again 2 oxygen because this oxygen we won't count, we'll count only this oxygen. So we'll see that things are balanced, right? So this is my balanced equation. Hope you understand this. The trick was here was this, in this the oxygen we won't count because we have already counted this oxygen, but we'll take oxygen from this guy OH because we didn't count the OH. Let's take few more examples. We have NOH, sodium hydroxide, plus H2SO4 sulfuric acid give Na2SO4, sodium sulfate, and water. So we have to balance this equation. So we already know the names of these things. We have learned all these things in the past classes. We want to balance this chemical equation. So here also if you see SO4 is 1 unit here. Here also we have SO4. That guy is my first priority. right? And do you have any metals? No. We have sodium, we'll take sodium. Then we'll take hydrogen and oxygen. This is the order of the priority. First we'll try to balance SO4 if it is not balanced. So let's check. So we have this SO4 and the HNO. So this is my reactant, this is my product. In this case, we see that SO4 there is 1 and here also we have 1 and 1. It's perfectly balanced. Then comes sodium. Sodium we have 1 here and 2 here. Oops, it is not balanced. So let's multiply this guy with 2. So the new equation we get is 2NeOH plus H2SO4 is equal to Na2SO4 plus H2. Let's again compare the values SO4, Na, HNO. We have reactant and product. So sulfate we have 1 here, 1 each. Sodium we have 2 here, 2 each. Hydrogen. So we have 2 hydrogens here plus 2, 4 hydrogens here. Here we have only 2 hydrogens, not balanced. So let's multiply with 2. 2 into 2 becomes 4, right? So what you get is 2NaOH plus H2SO4 gives Na2SO4 plus 2H2. Now let's again compare. This is SO4, NaHNO. We have this reactant, we have product. SO4 is 1. Sodium is 2 here, Hydrogen is 2 into 1, 2 plus 2, 4. Here we have 2 into 2, 4. Oxygen gone. So we have 2 oxygen here. This we won't consider because this we already consider as part of SO4. This also we won't consider. So we have only 2 oxygen atoms here. And here also we have 2 oxygen atoms, right? This is my balance chemical equation. Everything is balanced. Correct. We'll take a couple of more examples. NaCl, sodium chloride plus AgNO3, silver nitrate becomes AgCl plus NaNO3. So here, silver is any compound? No. Metal? Yes. Silver is the metal. Any compound? Yes. There's a compound, man. There's a compound. NO3 is a compound. So we'll take NO3 first. Then we have metal. We'll take metal Ag. Then we have non-metal sodium and chlorine. First we will try to balance this guy as NO3, then we have Ag, Na and Cl. We are reacting this guy product, right? So NO3, how many NO3 here? 1. How many here? 1. 1 balanced. Ag, how many Ag in reactant? 1. In product 1. Sodium, how many sodium in reactant? 1. In product 1. Cl, how many Cl in reactant? 1. Product 1. You see it is balanced. It is already balanced. So there is no need to balance. This equation is already balanced equation. We don't do anything. It's already balanced. Let's take one more example. Barium chloride BaCl2 plus H2SO4 sulfuric acid give barium sulfate PaSO4 plus HCl. Let's see. So we have SO4 thing here, both sides. So SO4 is my first priority. Then we'll take barium, is the second priority. Then we'll take chlorine, is the third priority. And here we see that some hydrogen is also there, right? So we'll take hydrogen as the fourth priority thing. We'll compare now. We'll see sulfate part. In reactant we have 1. In product we have 1. Sulfate is 1. Barium part. Yeah, next is barium. Barium we have 1 here, balanced. Next is chlorine part. We have 2 chlorine here. Reactant product we have only 1 chlorine. Oops, it is not balanced. Let's multiply with 2. Correct? So what you get is now barium chloride plus H2SO4 gives barium sulfate plus 2HC. Now again let's see the balance part SO4, Ba, Cl and H, right? My reactant is my product. So sulfate is how many? one here, one balanced. Barium is one here, balanced. Chlorine is two here, balanced. Hydrogen part. So we have two hydrogen here and two hydrogen here. Correct? Balanced. Everything is balanced. That means it is my balanced chemical equation. It's my answer. Balanced chemical equation. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.